So we are very excited by this because Cancer Cell is one of the topmost journals in cancer science and clinical science. First of all, it's extremely difficult to get into a journal like Cancer Cell because Cancer Cell has such a high impact. It's like a dream of a scientist to get published even once in Cancer Cell is like a big thing. One of the top American scientists just wrote to us yesterday when they saw this come out. And he said, throughout my career, I've never had the cover art as well. Right? To get the cover art as well as the article published is like a very tall order. This is the second time we've done that. And the reason why they seem to have clicked onto this cover art is because the pathway of how our therapy works in terms of cancer treatment is exceedingly complicated. It's completely new in the world. And the entire pathway we depicted in a single piece of artwork. What we have here is our nanocell. The nanocell is packaged with a very poisonous drug. And on the surface of the nanocell, we have these molecules that are able to recognize proteins that are found on cancer cell surface. Now, when these EDVs are running around, wherever there's a cancer growing, the blood vessels surrounding the cancer are all very defective. They've all got big holes in the walls. So consequently, what is happening is that these particles, as they're running around in the blood, they very quickly drop out of these holes and get into the cancer environment. Now, because they have the targeting system on their surface, they lock onto the cancer cell surface receptor. And when that happens, the cancer cell is automatically provoked into swallowing the entire EDV. Like a Trojan horse, it drags it inside the cancer cell. The EDV particle is broken down by the cancer cell and the poisonous drug payload is released inside the cancer cell, and that's how these cells die. In the body, there are several cells of the immune system which are well known to be cancer fighters. But the problem in cancer patients is as the cancer burden advances, those cells of the immune system are doing nothing. They're being suppressed. So what is happening with our pathway is that the other EDVs that are still in circulation, they see these blue types of cells, which are called natural killer cells. And what they do is that whenever they see an EDV particle, they think, oh, this is of bacterial origin. So they get excited and they run into the tumor environment. When they get into the tumor environment, they still see a lot of living cancer cells. So they are very aggressive, these natural killer cells. They lock onto the cancer cell and then they shoot out these little bullets that blows holes on the surface in the membrane of the cancer cell, and that's how these natural killer cells, once they're activated, are also able to kill some of the cancer cells. Additionally, there's another type of the immune system cell type, which is also very aggressive type of cell, and that's called a macrophage, shown as these purple cells in this pathway here. These macrophage type of cells, they go into the tumor environment, and you see all these dying tumor cells. They actually go after the dying tumor cell. They swallow the dying tumor cell, and what they do is they break down the dead tumor cell and display everything that they found on the tumor cell. So these are the yellow proteins that they found on the tumor cell, which they display on their own surface. Now, what these cells have to do, they have to go and tell somebody to do something about the situation because this is what they found. So what they do is they run into parts of the body that are called lymph nodes. And there's the real super killer sitting there. So this green type of cell is called a CD8 positive cytotoxic T cell. So these cytotoxic T cells, these are the ultimate killers in the body. But normally, they just sit there, do nothing. They have to be told by somebody else that, look, in the body over there, we found this thing. Then these guys get totally activated. They rush off to wherever they've been pointed to, and they will kill the danger enemy. So what these macrophages have done is that they show these new tumor antigens to this cytotoxic killer cell. So it takes a photocopy of these new antigens. And then it runs off back into the tumor environment, and wherever they see a living cancer cell, they shoot these bullets and they kill them. The drug-loaded EDVs is only starting the game. The game is actually finished off by the cells of the immune system, being the killer T cells. There's another type of a cell called the dendritic cell. They do the same thing as the macrophage. They swallow the dying tumor cells, they display the tumor antigens on its surface, and then they go also into this lymph node. They show it to the new antigens to the cytotoxic T cell, which then runs in here and finds the rest of the tumor cells and kills them off. So in this entire pathway, there are two major things happening. One is that the EDVs carrying the poisonous drug are initially starting the game by killing some of the cancer cells. The rest of the EDVs are being picked up by cells of the immune system, which then get activated in various ways and go and show these final killer T cells what they've found, and then these killer T cells come in here and kill off the rest of the tumor. Now, we are the only ones in the world where with a single technology, without any further manipulation, is able to actually do all of this. All other the leading technologies in cancer treatment, what they aim to do is they either throw something toxic at the cancer cell to try and kill the cancer cell. But the problem with that strategy, and we've seen this over the last 60 years, so many different drugs developed, but the cancer cell always mutates and becomes resistant eventually. Killing the cancer cell is definitely not the answer because it will never achieve 100%. The other types of strategies are that they also know that some of these cells of the immune system, while they are able to kill cancer cells, problem is they're asleep. And because when a cancer is growing, it shoots out a lot of molecules that shuts down this whole pathway. Consequently, what people are trying to do is activate a dendritic cell, or activate a killer cell, or activate this type of cell. It's a piecemeal patchwork. That patchwork is never 100%. So 1 out of 20 patients will do well, 19 will fail. Here, we have used a decoy. We fooled the immune system into thinking you've got a bacterium. So we have bypassed the whole pathway of immunosuppression. We've activated a new way to activate all of them and finish this job. Once you do this pathway correctly, the result in a cancer patient is truly remarkable. That even an end-stage cancer patient who is within days from death can be saved if you can do this. And we have now demonstrated in several of our patients that yes, indeed, activated correctly, this is truly unique. And you don't have to do anything else. Once you've injected the EDVs go and do all of this in a physiological way with no toxic side effect. Every patient who has done remarkably well, where the tumor just rapidly disappeared, was because of this, not because of killing cancer cells. Killing is the first step. Finishing the job is these guys.